tired.
Oh, no, I already am.
The yawns made me tired. I didn't yawn, but I'm like, oh, I wish I could go back to bed.
Has there ever been an argument as to why yawns are contagious, like biologically? Like, what a yawn is your brain getting more oxygen, right? I mean, right? That's the physiological point of it. So has there been a biological argument as to why seeing someone else yawn makes you yawn too?
I know that in high school we used to sit in class and I get the teacher to yawn.
Oh, really? Like faking yawns with the... that's funny. That's funny. Nobody's ever heard one though? That's too,
Probably has something to do with being tired.
But maybe not breathing as deeply as you should.
Yeah.
Okay, I'll buy that. Yeah, it's all theory anyway. All right, grab a template. Let's knock this thing out. Let's go through it step by step. You now know what the number being kicked out is going to be. Now we understand its placement. So, Di's already answered question number 1. We are testing mu. As a matter of fact, we're testing 2 of them. So we have to have 2 mu's to discuss. mu1 and mu2. They are 2 independent averages. What were we calling mu1? It's running yawns. Cantilever what?
23.4.
That's the sample data. I'm talking about mu now. What are we interested in? For example, what Angie and Sherry just collected on you guys was a percentage of you that yawned in the class for certain slides, yes? But they're not interested in you as a class, they're interested in people in general. So they want to extend it to the entire population. So I took a sample, I got X bar was 23 feet. But I'm interested in all of the what? The population of what kind of brakes? Cantilever brakes. So I'm interested in the average stopping distance for cantilever brakes. It's a lot of shorthand, I apologize. So what I'm interested in, this is my sample, but I have to change my sample to make it differential. So I'm interested in the average stopping distance for cantilever brakes. That's mu1. But I'm also interested in what? The average stopping distance for the other ones for V brakes. I'm also interested in the average stopping distance for V brakes. Yeah.
Should we use the second sheet?
No, use all. Thank you. Great question. I don't want you to use the second sheet, because if you use the second sheet, how many tests are you going to run? 2. I don't want to run 2 tests. I want to run 1 test. Why?
Just want to see the difference.
Because I want to see the difference, and if I run 2, I could theoretically run 2 tests. I could run the confidence interval on mu1, interval on mu2, and compare them. What have I just done? I just lost confidence. Whenever possible, I want to slam all this stuff into 1 test. Whenever possible. 1 test maintains my confidence. So thank you for the question. 1 test, 1 template. All right. So now we need hypotheses, yes? I like going H1 first, personally. What was I running the test to see? If
V brakes stop sooner on average than.
Good. I'm going to put that in words first. Don't write this on your sheet if you don't want to. I'm going to put what Danielle just said in words right under this. Okay, actually, I'll do it with color. I love that, but you said it perfectly. I want to see if V brakes stop. Can I say in less distance? Is that okay, Danielle? Is that okay? Well, because you said quicker, I think you said quicker, and that implies sooner. But that implies time, but we're actually measuring distance, not time. So if I go stop in less distance than V brakes, is that okay?
Yeah.
Or then cantilever brakes, excuse me. Can you say that symbolically, using the muse?
U2 is less than U1.
Beautiful! Say it again, nice and loud.
U2 is less than U1.
Everybody following that? If we want to take Danielle's beautiful idea and use the symbols that we've got up here, I want mu1 to be bigger than mu2. Or as Ola said, mu2 is less than mu1. Both are correct and equivalent, correct? You can write it either way. mu1 is bigger than mu2, or mu2 is less than mu1. I'll keep it numerical by putting the 1 on the left side. Is that okay? Excellent. That's our claim. What goes up top in the null? The opposite. And you know what's funny? I got a question from another grader who happened to be watching the videos from our class and was looking at our quizzes. It was in grade 244, but happened to walk in and was interested in 244 stuff. And she said, I always thought this was equals up here. Remember what I mentioned to you guys about in the research, very often this is always equals, not necessarily the opposite of this? And when I explained to her why we do it this way, she's like, oh my God, that makes so much more sense. It does. It does. Because this is what you're testing, and this is everything else. Yeah? And this is everything else. But the thing is, be ready for that. When you get to the research, very often the null always has an equal sign. Even if it should be a less than or equal to or greater than. A lot of times they'll just print an equal sign. Just be aware of that. The important one is this one anyway, which you're testing down here. Notice it's a rectangle test. It's a rectangle test, greater than. So what you want is you want to see somewhere out here, there's a cutoff. There's a cutoff that says, okay, we've gotten so far out that now it's statistically significantly higher. And when I say higher, you might think to yourself, wait a minute, we're not looking for higher, we're looking for lower because we want the V brakes to be less distance. But the way we've set it up, mu1 greater than mu2, we want that to be large, don't we? Because this being large implies that this is smaller than this. Does that make sense numerically? If this number is really positive, it means the cantilevers require more distance to stop than the V's. This minus this. Is that fair enough? You guys buy that logic? Good. So now the question is, let's analyze the errors that are possible. What would a type 1 false positive be? That's a good generalization. I love that, Danielle. Saying something changed, but it didn't. I like that. It's false positive. Give me a context of the problem.
Saying that the V brakes stop at a shorter distance, but it actually did.
I love that. Saying the V brakes have a shorter stopping distance when they actually don't. I love that. That'd be a false positive. False negative would be? Saying the V brakes don't stop in less distance when they actually do. So I love Danielle's generalization of false positive, false negative. False positive is always saying something's different when it's not. False negative is always saying something's not different when it is. That's always the generalization. Perfect generalization. The kicker is, for this one, you have to put it, or for all, you have to put it in context. So false positive is saying the V brakes are better when they actually aren't. False negative is saying the V brakes aren't better when they actually are. Good. I love both of those. Which one do you guys think is worse? Type 1? Tell me why.
Because it's important that people know when they're going to stop for your corner.
Okay, so in other words, if you have a test that shows me that V brakes are better, but they're actually not better, they're either the same or worse, and I put V brakes on my bike, and I remember in the study that I read that said V brakes have way better stopping power than cantilevers. What am I going to do? Maybe.
Crash.
I'm maybe going to go much faster thinking that the V brakes actually work better. So I'm flying into turns at 25 and 30 now because I'm like, I got V brakes, everything's fine until it's not. Then I go off this. Good! I like that type 1. I totally. Who says type 2? Anybody say type 2? No? I can think of a reason type 2 might be bad as well. Yeah. Because if you actually do have a difference, if V brakes actually are better, but the report doesn't say that, number one, you might treat V brakes as the same as cantilever brakes, but if they actually stop better, you might go over the handlebars because you grab them too tightly. Very, very good. Or you might hide a safety from the public. If you come back and say, V brakes aren't any better, you're unknowingly, of course, unwittingly and unknowingly, hiding a safety measure from the public, yes? In other words, they are better, but you're not letting people know about it. So I can see either one being bad. Another one would be financial. If you report that V brakes are better, that's an investment in time and parts that you have to change the bikes over to V brakes when it wouldn't be any difference or an immeasurable difference. Good. I love this. This is good. Everybody see both? You can't be wrong. You can't be wrong on which area you pick. Just tell me why you picked the area you do. That's what I always care about. That's what I care about, breeding good researchers like these guys that came in today. Breeding good researchers, making sure that you guys can think about how to set up an experiment and what you care most about. Good! All right, I think we're ready to test proper. Yes? I think so. Test statistic. We know what distribution we're using already.